Hey guys, welcome to Giraffe Labs. My name is Alex, and today I built for you this, the automatic Nerf turret. For this explanation, we're going to split it up into three parts: the mechanical, the electrical, and the software. So, first for the mechanical. So, you may wonder, how are we going to get this thing to move in the first place? In order to do that, we're going to use what's called a servo motor, which is what you can see right here, and there's also one all the way down here. These motors can very precisely move to a certain angle given it to it by a computer. So if I tell it to move 45 degrees, it'll go to exactly 45 degrees every single time. And this is very useful when aiming. Now, these two combined form what we call a pan-tilt system. Pan meaning we can move it in the X direction, so left and right, and tilt meaning we can move it up and down. And this allows us to create a very nice field of view, and we can aim anywhere we want just by entering a set of coordinates into there from pan and tilt. Now onto the electronics. This is going to get a little complicated, so try to stay with me, please. So we're going to start with the laptop, which runs the main program. And this either gets input from the controller if it's in manual, or the camera if it's in automatic. Either way, it will pump its commands to the Arduino, which is a microcontroller. And the Arduino has a two-way communication with this Raspberry Pi. And the Raspberry Pi is basically a mini computer. And it will host a web server on the open web, which hosts an app. And this app will directly control the turret in some certain modes. Now back to the Arduino. The Arduino will pump its commands into the pan-tilt servos and the firing mechanism, which we will talk about shortly. The servos are directly powered by an external power supply because the servos draw a lot of energy that the other parts of this just can't handle. Finally, these servos directly interface with the camera by moving it, as you could see before in the mechanical section, which completes the feedback loop for the automatic section. If you want a more technical description, you can read the README in the GitHub down below. So now you may be wondering, how are we going to fire this Nerf gun? Because before I had a little thing that just said a firing trigger, but we never really defined what that meant. So normally when you fire a Nerf gun, you squeeze a trigger, right? Now what that really does internally in a lot of Nerf guns, including this one, is when you pull it, it will interact with a switch inside, which will activate a motor, which will actually fire the gun. So what we're going to do is we're going to replace it with an electronic switch, or what we call a relay, and I have one here to show you. So you power this side, and when you apply a signal here and you make it positive, it will switch from connecting the middle and the left to the middle and the right. So we can just attach our two wires to the middle and the right, which are these two, and these will go to the firing motor. And then our Arduino just has to change the signal on this side, and it will send the signal and fire the gun. Now for the software part. So first off, there is the manual software, which is kind of trivial. It just pumps commands directly from the game controller into the laptop. However, the more interesting one is the AI version. So in the AI version, now this is massively oversimplified. If you want technical details, it's in the GitHub. So we draw a dot at the center of our screen first. This is our aim point. This is where the gun is currently aiming. Then we use a computer vision model called YOLO V8, which detects any humans in the area. Then we draw a dot on our target, and this is now the target point. And all the program tries to do is move the servos such that the aim point is on top of the target point. And it will keep repeating this many times per second, and that will track the target. Again, more technical details in the GitHub down below. So you may be wondering, how do you start up this whole thing? So first you have to turn on the main power supply, then you have to turn on the servo power supply. Then you come over here and you got to start your main program, and you got to start your web server program. And once you start your web server program, then you have to port out your web server program to the open internet. And then you just come over here, just wait a second, and you got a fully working turret. Anyway, now what you all came here for. It's time for shooting. So, first we're going to explore the manual control. In order to do the manual control, you need to use an Xbox controller. So for this demonstration, I have my little sister Sammy here, and she's going to be our target. So you can use the left joystick to go left, right, up, down, and you can also use the D-pad to select your speed, so we can go medium or fast. And you can also use A to recenter yourself. And then all you have to do is pull the and it shoots. So now let's test the automatic mode. So this, instead of being controlled by an Xbox controller, is controlled by our app. And our app can be used anywhere on the internet. So now, when our test subject walks in, you can see it'll start tracking them after a second or two. There we go. Now we have a good track. And then all we gotta do is press the button. Or, if you're feeling lazy, you can use the automatic fire feature, which will automatically start shooting at somebody after a predetermined time delay. Here we have 2 seconds. So, if we click this, and our test subject walks in, and then afterward, it will reset to 0. Thank you guys so much for watching. This has been Giraffe Labs. Unfortunately, I'm going back to school in a few days, so I don't know when my next upload will be. This project has been a long time coming, and this is actually the 2.0 version of this project. I made the same project last winter, and this one I think is a lot better, and I definitely learned a lot of lessons from that last time. Thank you guys so much for watching, and I'll see you again next time.